I just ran out of time there, but we have one more problem to do. I looked over just as it said, like 14 minutes, 59 seconds. So here's a problem for you to try out. It's the same instructions. Find the interval of convergence for the function, its derivative, its second derivative, and its antiderivative. And this will take you a little bit, but this will be really good practice, and we'll go through it one more time. I'll pause it and give you a chance to do stuff, and I'll write some things down to save ourselves some time later on. Okay, first section done. Here's my ratio test information, and then I did lots of flippy trick, and I just group stuff. I say, okay, well, the x minus 5 to the n plus 1 is in the numerator, and the other one's in the denominator, and this n plus 1 is in the denominator of the numerator, so it goes down to the denominator, and then the second denominator flips up and goes to the numerator. And same with this one, 5 to the n goes all the way up to the numerator, and 5 to the n plus 1 is the denominator. And then I just simplified each one. Then we take the limit as n goes to infinity, and this is the only thing that has an n in it, and so it just goes away and becomes 1, and we got x minus 5 over 5. Now it's a ratio test, so we want, for this to converge, we want this to be less than 1, and now we're going to solve it. I'll pause it there. Why don't you pause it and just solve that yourself. See if you can remember how to do absolute value inequalities like that. And here it is solved. Absolute value less than a positive number. Just set it between the positive and the negative, and then solve it normally. I never multiplied it or divided by a negative, so the signs never flipped. So that's the interval without endpoints checked. And then what was I going to say? I was going to say something. Oh, and so the radius of convergence in this case is 5, just for the record, because it's halfway in between. You know, it's I should say that better, because half of the span of this interval is 5. All right, now we got to just check the endpoints. And so we're going to start off with x being 0. And so if x is 0, so we're going back and we're taking this series that we're looking at, which is the original series, which I have to find here. Where is the original series? Oh, there it is. Oh, and I just realized I had a little bit of a mistake, or a thing I didn't say. I ignored the -1 to the n plus 1 because when I'm doing the ratio test, it doesn't matter because the absolute value is going to kill that. So that's why that went away. But now it actually is important, so I have to write x equals 0 and say, all right, now I'm adding up, and I'm doing that original sum, except I'm just turning all the x's into 0 to see if this thing is going to converge or not. So it's -1 to the n plus 1. Here, I should shrink it a little bit, make it a little easier on myself. So it's -1 to the n plus 1. And then plug in 0 for x. So that's -5 to the n. And I'm just going to get rid of that. There we go. -5 to the n over, and it's n 5 to the n. There we go. Now I've got it written down once. I'll be okay. That's one negative there. So and so let's just write out what this thing is. This is n equals 1 to infinity and see what it is. So plugging in 1, plugging in 1, you get -1 squared, so that's positive. So it'd be -5 over, hey, wait a minute, before we do this, maybe it'd be easier if we canceled some of this out here. So we've got -5 to the n over 5 to the n. Why don't we cancel that out? So we can rewrite that as n equals 1 to infinity. And we've got -5 to the n over 5 to the n. Well, that's just going to be, here's the one that's already there, but that's just going to be -1 to the n over n. Oh, that's a little easier. So does this converge or diverge? Well, I mean, there's no x's in here. Let's list off what this thing is and figure it out. So first we're going to plug in n equal to 1. Well, this one here then is going to be positive because it's -1 to the n, to the second. But this one's going to be negative because it's -1 to the first. So it's -1 over n is 1. 1 plus. Next one. Now we plug in n equal to 2. -1 to the third, that's negative. -1 squared, that's positive. So it's again negative. Oh, one of these is going to be positive and one of these is going to be negative every time on this one because they're off 1 unit from each other and they're little toggles toggling positive versus negative. So every time it's going to be negative because it'll just switch back and forth which one's positive, which one's negative, and you're just going to have n in the denominator. So it's plus negative 1/3 plus ... Weird. So negative 1/2 plus negative 1 plus negative 1/2 plus negative 1/3. This is just a harmonic series times negative 1. It's negative 1 times 1 plus 1/2 plus 1/3. And this thing plus ... goes to infinity. So it's going to be negative infinity. So it diverges. Weird. Okay, how about x equals 10? So we try x equals 10 in here. We go and so now all that would be different. Going back to that original one we had, we're turning all the x's into 10s. Oh, sorry about that. And saying, does this thing converge or diverge? Don't want to look at that. Don't want to be scared by next class. And so plugging in all the x's being 10, got it written down here for me. It's going to be still negative 1. Negative 1 to the n plus 1. There's no x's there. This is n equals 1 to infinity. And it's then just going to be 5 to the n. Instead of before it was negative 5 to the n, now it's just going to be 5 to the n over n 5 to the n. And so now I can just plug things in. It's a pretty easy one here. 1 goes in and it's positive, so it's 1 over 1 plus 2 goes in. Now it's negative because it didn't create an extra 1 over here, and it just created 1 over here instead. So it's plus negative 1/2 plus 3 goes in. It's positive again, 1/3 minus 1/4 plus ... This is the alternating harmonic. And we harmonic, and we know that converges. And so the original problem, the interval of convergence is that 0 doesn't work. This is the IOC. The 0 doesn't work, but the 10 does work, and I can give it a bracket. Whew. Now, next up, we've got to figure out how to get rid of that bracket. There we go. Let's get rid of that. Next up, we have to take the derivative and the second derivative and the integral and check the interval of convergence on all those. And I'm looking at it, I'm realizing there's no way I'm going to make it here. So I better put in a bunch of returns here so that I got enough space. I did all this on a separate page. So I'm just scrolling it down so it's out of our way so we can do the problem. Now that obviously is going to take a long time to do all that. You can see why this is a big chunk of the work you're doing today. So I'd encourage you to try it out for yourself. And what I'm going to do, I'm just going to pause it, give you a chance to try them yourself, and I'm going to just post the answers. The work would take a long time to put all down here, but I'll post the answers of what the derivative, second derivative, and integrals are, and the interval of convergence for each. So I'm pausing now. I lied a bit. I think it's worth it to actually show the derivative and talk it through. I've got my answer here, but I thought, I should say something. So what's the derivative of this thing? And then I'll pause it and just put the answers down. So the derivative, what you have to focus on is just focus on the x. We're doing the derivative with respect to x. So that means that this is what we're taking the derivative of, and all this other stuff is just coming along for the ride. So it's going to be the sum from n equals 1 to infinity of, and it still has a negative 1 to the n plus 1 there, and it still, for a moment, has an n 5 to the n, but now we multiply that down, so it becomes n x minus 5 to the n minus 1. So that's the key. Taking the derivative is actually pretty easy because there's only one x in it, and so all these n's are just going to be the things that generate all the terms, but the x is the thing we're taking the derivative with respect to. So the n's cancel out, and you've got your nice derivative formula. It's just x minus 5 to the n minus 1 over 5 to the n with a alternating series in there. Okay, now I'm going to really pause it and just put answers down. Okay, so we have our derivative, and we're just checking the endpoints because we know that the interval of convergence, the basic stays the same. We just have to check the endpoints. When I check x equals 0 and plug it in, I end up having to do a little weird simplifying. It's a little tricky to simplify, or you could just list out the terms if you wanted to. That might take a while though. And I end up with this thing. But what I realized is that the denominator isn't getting any bigger. I've got a 5, negative 5 to the n and a 5 to the n, and they cancel. And so the denominator is not getting bigger. This thing's not heading to 0. So it's going to diverge by the nth term test. And I don't really need to worry about too much about it because I can see that the limit of this is definitely not 0. And the same is true for 10. You got the same issue where the 5 to the n minus 1 and the 5 to the n cancel out, leave you an n 5 to the negative 1, which ends up in the denominator. But that diverges also because of nth term. So the interval of convergence doesn't include either endpoint. It's just the denominators aren't getting any bigger. I'm just going to put the answers down here, and we won't show all the work. Need a little bit more space. More space. Must have more space. There you go. And so I'll let you know what I got for the second derivative was, where is it? I got that it was the sum from n equal 1 to infinity of, where is it? There it is, of n minus 1 times x minus 5 to the n minus 2 over 5 to the n. Double check that. Look at it. Oh, with the negative 1 to the n plus 1 also in there. And I ended up getting that both endpoints on this one diverged also. And so I got the IOC was I'm just looking at it again right now just to make sure I agree with my assessment. Now I've got myself kind of spooked. But yeah, the denominator is not going to be getting any bigger, so it's not going to work. And so I got an IOC of 0 to 10. And finally, the integral of f of x dx is equal to, and I got that to be the sum n equals 1 to infinity of x minus 5 to the n plus 1, with that negative 1 to the n plus 1 up there, over n times n plus 1. I hope this is right, times 5 to the n. I did this all on paper here. And this one, when you plug in both 0 and 10, they both converge, because what you end up getting is a lot of stuff canceling, but this n and n plus 1 in the bottom here can converge because of the p series. You know, it's going to be a p series with that stuff in the denominator. And so I got the IOC to be 0 to 10. Okay, I'm going to stop it there. Well, I'm going to just summarize. So, I mean, this was a really hard problem. I probably should have thought twice about taking this one on, but we all make our questionable decisions sometimes. And there we go. And so the big thing here is taking the derivative or integral of a power series and how it affects the interval of convergence, which is very little. And I've asked you to do a couple of problems for practice for tonight, just a few, because I know that going through these videos probably took you a while. And so I just have a few for you to do from 9.8. We finish 9.8 on Friday. We'll move on to 9.9. Please let me know if you have any questions. And that's it. Take care and hope it goes well. This is probably algebraically as tough as it gets, and it'll be better from here. All right. Bye, guys.